Welcome back, my friends. As promised in the previous video, today we're going to delve deeper into Python's conditional structures. In the last video, we got familiar with the core of if statements, which include if, elif, and else. And you saw how useful and practical this conditional structure is. We also solved a scenario together, showcasing how effectively we can use these conditional structures to organize our scripts or programs for network management. Now, let's explore how we can use these conditional structures more effectively and tailor them to our needs. If you're curious about this, please stay with us. First of all, let's dive into using operators and conditional structures. If you're not familiar with operators, don't worry. I've discussed them in Python in this video, and you can find the link up here. But if we want to summarize, the operators we use in conditional structures in Python include comparison operators and logical operators. Comparison operators include equals, not equals, less than or equal to, greater than, and greater than or equal to. Logical operators includes and, or, and finally, not. Great. To better understand, I'll use a few simple scenarios. The first scenario. Imagine you are a network administrator responsible for monitoring the performance of your organization's server. You want to ensure that network response times stay within acceptable limits to maintain a smooth online experience for users. Your maximum acceptable ping response time is set at 20 milliseconds. Okay. In this scenario, you want to create a Python script that checks the network conditions and provide real-time feedback. Here's how you can use Python comparison operators to evaluate the situation. All right, let's write it together. First of all, let's add a brief comment for this code. For example, let's say network response time conditions. Okay. After that, let's set an assumed number for the current response time, like 15. I'm using a number less than 20 here because the scenario mentioned that the acceptable response time is 20 milliseconds. Now, we need to assign this number to a variable. So, let's create a variable like, for example, ping underscore response underscore time and assign the number 15 to it, like this. Ping underscore response underscore time equals 15. Okay? Great. Now, we need to declare the acceptable response time as well. So, let's define it like this. Max underscore acceptable underscore ping equals 20. All right. Let's move on to writing our conditions and see how comparison operators help us write these conditions that suit this scenario. Now, what I need to do is to use an if statement to compare these two values, which are the values of the ping response time variable and the max acceptable ping variable. It would look like this. If ping underscore response underscore time equal max underscore acceptable underscore ping, and a colon to form the if block. Now, Under this condition, I need to specify what to do if these two values are equal. For now, I want a very simple action, which is to have it print the message like, for example, ping response time is equal to maximum acceptable ping, okay, as an output. So I'll use the print function to make it do that like this. Print ping response time is equal to maximum acceptable ping. Okay. Great. Let me fix it. Great. But our work is not finished yet. We need to check other scenarios as well. For example, it's a good idea to check what it should do if ping response time is less than max acceptable ping, and vice versa. So, after exiting the if block, I move on to the next condition with elif like this. Elif ping response time less than max acceptable ping, and again a colon at the end to check the next condition. Here, once again, I want a simple request using the print function to display a message if this condition is met, stating that the network is performing well. It would look like this. Print ping response time is lower than the maximum acceptable ping. Okay, so network is performing well. Very good. That's about it. Now, let's move to the opposite condition. So, I exit the elif block and continue to create another elif block like this. Elif ping response time greater than max acceptable ping, and once again a colon at the end. Again, I wanted to use the print function to display a message if this condition is met, indicating that your network may be experiencing delays. It would look like this. Print ping response time. Let me fix it. Ping response time is greater than, is higher than the maximum acceptable ping, and therefore network may be experiencing delays. Very well. Now, it's time for the final overall condition. That means if none of the above conditions are met, what should our program do? As I mentioned in the previous video, here we use an else block. it looked like this. Else. And again a colon. And what do you think about having it print a message like unknown network condition, in the else flag? So once again, using the print function, I requested to do that like this. Print unknown network condition. Okay, all right. Now let's run this code together. What will be the result? We receive the message network is performing well in the output. Let's see. As you can see here, network is performing well. Network is performing well. Okay? Which condition has been met? It's the second one. Now, if I change the value of ping response time to, for example, 20, look like this. Which condition will be satisfied? Let's check together. Okay, ping response time is equal to maximum acceptable ping. Let me fix it. And run it again. Ping response time is equal to maximum acceptable ping. Obviously, if we set ping response time to be greater than 20, the third condition will be executed. And in the output, we'll encounter the message network may be experiencing delays. Let's see it together. Here is the result for the third condition. But wait a moment. When does the else block get executed? Well, it's clear. In this code I have written, the else block won't be executed because in the end, the values inside these two variables are either equal or one is greater than the other, right? I haven't considered another condition in this code for the else block to perform any action. So it can be said that I can safely remove the else block from this code without causing any issues in my program. To make sure, I'm going to comment out the else block and run the code again. But before, let's revert it back to 15. And now commenting out the else block and run the program again. As you can see, my code runs smoothly without any problems. However, there's a point to keep in mind. This situation doesn't apply anywhere, my friends. And the presence or absence of the else block depends entirely on the conditions you have set. Just make sure to understand the conditional structure properly, and then you'll easily figure out how to use it in different scenarios. Great job! By solving this scenario, you become familiar with the use of comparison operators in if conditional structures. And as we progress, you'll encounter more diverse examples and become even more familiar with them. Now, let's move forward and explore another scenario. In this scenario, I intend to familiarize you with the application of logical operators within conditional structures. Here's our scenario. Imagine you're developing a network monitoring system and you want to create an alert system based on a specific network conditions. You can use logical operators to trigger alerts in different situations. Okay. For this scenario, I want to consider three attributes and evaluate different network conditions based on them. As you can see, these three attributes can include current bandwidth, packet loss, and device status. In fact, here I have defined each of these attributes as variables and assigned hypothetical default values as current or default conditions. On the other hand, I've also defined undesirable conditions that should trigger an alert in the form of two separate values: high bandwidth threshold and acceptable packet loss. So, up to this point, everything is set up for me to use conditional structures and logical operators to examine the status of this hypothetical network in various scenarios and perform an action or simply display an appropriate message for each condition. Very well. How can we make Python recognize desirable and undesirable conditions according to the scenario? Let's write it together. First, let us start by specifying the desirable condition like this. If current bandwidth lower than or less than high bandwidth threshold and packet loss less than or equal to acceptable packet loss. Now, after the colon in the next line, we determine the action to be taken or the message to be displayed. Here again, using Python print function, we wanted to show us this message. If this condition are met, for example, print network is stable, no action needed. Good. Now, let's move on to the undesirable condition like this. We exit if block and write the next condition with elif. Elif current bandwidth greater than high bandwidth threshold or device status not equal or not online. After the colon on the next line, we specify the action or a corresponding message. For example, let's say print network issue investigate and take necessary action. Finally, using the else block, we examine other possible conditions that we didn't check in the previous conditions and specify a general action or message that applies to those conditions. Like this, else, for example, print, let's say other conditions apply. Very well. Just as simple as that. Well, let's quickly summarize and see what we've asked Python for this conditional structure and what it will do for us in return. In this scenario, the AND operator is crucial for assigning network stability. The script checks two conditions at the same time. 1. Current bandwidth below threshold. It verifies if the current bandwidth is below the specified high bandwidth thresholds. 2. Acceptable packet loss. Simultaneously, it ensures that the packet loss is within acceptable limits. For the script to print, network is stable, no action needed, both conditions must be true. If either the bandwidth is above the threshold or packet losses exceed the acceptable limit, the AND operator ensures that the script does not consider the network stable. Instead, it prompts further action or alert as necessary. The AND operator, therefore, acts as a logical gate, requiring both conditions to be met for the network to be deemed stable in this context. The OR operator is used to check if the current bandwidth is greater than the threshold or if the device status is not online. If either conditions is met, it's triggering network issue alert. The NOT operator, my friends, is indirectly represented by the use of not equal to in the condition. This script utilizes the not equal to operator to check if the device status is not equal to online. If device status is indeed not online, it triggers a network issue alert. The not equal to operator serves as the not operator in this context, ensuring that the script responds to the negation of the specified condition. Consequently, if the device status is anything other than online, the script initiates the alert, indicating a potential network issue that requires investigating and necessary action. It's essential to know that we can use other keywords such as not, is not, in, and so on in conditional structures. However, my goal here is to familiarize you with the use of operators and keywords in conditional structures. In this short video, I don't intend to cover all of them because in the upcoming videos and scenario, we'll gradually explore and understand their applications, especially in the network domain. All right. Now let's run the code together and examine the result by changing the variable values. One question. If I run the code in this current form, which condition do you think will be met? And what message do you expect to receive in the output? Take a minute. Pause the video and think about it. Good. Now let's see the result. As many of you guessed, the else block is executed because the current state of the network, or in the other word, the value assigned to the variable doesn't match the conditions specified before the else block. All right, now let's change the value of one of the variable and we evaluate the result. For example, let's change the value of the variable device status to offline. Offline. Okay. Now, which condition do you think will be met? Pause the video for another minute and think about it. If your answer is the second condition, the else block, you're absolutely correct. Let's see the result together. Just as we expected, the message network issue is displayed. Great. Now, in your opinion, which variable's value should I change for the first condition to be met and execute? Pause the video for another minute and think about it. Well, you probably come up with a few options, right? One of the options is to change the value of the variable packet loss to a number 3 or less. I'll change this number to 2. But before that, let's back it to online. And packet loss to 2. Let's see the result together. Since the current value of the variable packet loss is less than the value of the variable acceptable packet loss, the first condition is met and the message network is stable is displayed, as you can see here. To execute the first and second condition in this code, what else can we do? Please write this code and try different values for the variable to examine various scenarios of the first and second conditions. And please share the results in the comments. Great. Now, as a final point in this video, I want to familiarize you with another aspect of conditional structures and its applications in the networking world, which is the nested if. Well, the first question is, what is the purpose of a nested if? In response to this question, I must say that nested if statements are used when you want to have multiple level of conditions or when you need to examine an additional condition based on the result of a previous one. Okay? For better grasp of this topic, consider this sample code. Here is it. Here, I initially define two hypothetical variables named condition 1 with the value x and condition 2 with the value y. In the first if block, I wrote hypothetical code related to the fulfillment of condition 1. Inside the second if block, which is nested within the first if block, you can see the hypothetical code related to the fulfillment of condition 2. Following that, I wrote an else block corresponding to the inner if, indicating what should happen if condition 2 is not met. Finally, the else block related to the outermost if indicate what should happen if condition 1 is not met. Okay? A point to note in the structure of nested if statement is that the inner if block is evaluated only if the outer if is true. In this case, if the outer if is not true, the outer else block is executed. Similarly, if the inner if is not true, the inner else block is executed. This structure provides a way to handle more complex scenarios where conditions depend on the fulfillment of other conditions. Additionally, as you can see, I use the pass keyword for each of the if and else blocks. This is because I can't leave an empty condition statement, or otherwise the IDE would show an error. So, in such cases where you want to create a placeholder for a block that you will write code for later, the pass keyword is useful. Great! We have reached the end of this video. If you found it helpful, please consider subscribing and turning on notifications. This way, you'll stay updated on our upcoming videos. If you like this video, giving it a thumbs up and sharing it will contribute to reaching more people interested in these topics. Thank you for your attention to this video.